Alrighty, welcome to chemical reactions and chemical equations. We're going to learn about what a chemical reaction is today. So we're going to be able to state what a chemical reaction is, and then we're also going to identify the parts of a chemical reaction, and we're going to talk a little bit about what happens when a chemical reaction occurs. And then our final thing is we're going to do this thing called balance. We're going to be balancing elementary chemical equations. So first of all, let's talk about this word diatomic. There are some atoms or some elements on the periodic table that whenever they are by themselves, there's always two of them. And one of the things that we need to understand is that, for example, when you say hydrogen, hydrogen is one of these elements here. Whenever it is just hydrogen, hydrogen is always H2. You never write hydrogen as just H. Okay, so an easy way to remember what those diatomic molecules are, and you do need to know this, is by using the acronym that is Brinkelhoff. Okay, so Brinkelhoff are these 7 elements that when they're by themselves, there's always 2 of them. So whenever I say bromine, you say Br2. Now that doesn't mean that if it's with something else, it's always 2. For example, sodium bromide, we should know, is just NaBr. Notice the bromine is not by itself, so it can just have one bromine. Okay, so these are something that you need to commit to memory, and if you remember the term Brinkelhoff, you'll remember that it's these 7 that anytime they're by themselves, there's always 2 of them. Okay, so when things react with each other, what happens is the atoms of one or more substances are simply rearranged. One of the labs we're going to do here in a few days deals with this rearranging of atoms. You don't lose atoms, you don't gain atoms, you can't, because there is a law that's called the law of conservation of matter, which means you can't create new matter and you can't destroy matter. Whatever you have, whatever you start with, you must end with that same amount. So that is called the law of conservation of matter. And that is, again, what tells us that you can't destroy matter or create new matter. And then how do we know if a chemical reaction has happened? Okay, a lot of times you'll feel it. It'll get hot. It'll get cold. You'll see a color change. It'll go from colorless to white or colorless to yellow, something like that. You might even smell it. You might see some bubbles forming. You might see a solid form and sit on the bottom. Obviously, if something burns. So usually, just from some visual evidence, you can tell that a chemical reaction has happened. Now, when we have a chemical equation, there are certain parts of it. There's certain words that we use to describe it. First of all, on our left-hand side, so you'll notice this arrow right here. That arrow separates the reactants from the products. The reactants is exactly what it looks like. They are the things that react. They're the things on the left-hand side of our arrow here. The products are what are produced, and they're always on the right-hand side. So the things that react, the reactants, are on the left-hand side. The products, the things that are produced, are on the right-hand side. And sometimes we have these numbers in the front, some on the reactant side, some on the product side, or sometimes not at all. What those numbers are called is they are called coefficients. So a coefficient is just a number that tells you how many of each molecule we have. So in this case, we would say there are 2 molecules of hydrogen that react with, that's what that plus means, reacts with 1 molecule. Notice there's no number in front of that oxygen. There's no coefficient for oxygen. So we say that 2 molecules of hydrogen react with 1 molecule of oxygen to produce, that's what our arrow is, 2 molecules, again, there's our coefficient 2 molecules of water. So you need to know what reactants are, you need to know what products are, and then also what coefficients, what that term means. And then the arrow, as we saw here, means to produce. Now, sometimes we write chemical equations using words. So in this case, we can say iron and chlorine react to produce iron 3 chloride. Sometimes we write them as actual using the elements. So iron, which is a solid, that's what that letter S stands for, is solid. So S is solid. Chlorine is a gas, so G is gas. And then sometimes you'll see the letter L, that's a lowercase l. That obviously stands for liquid. And then one more that you might see, or you definitely will see, is AQ. And AQ stands for aqueous. And what aqueous means, it means you've taken something and you've dissolved it in water. For example, if you take NaCl, which is a solid, it's just salt, and you put it into water, well, now it's not solid sodium chloride anymore. You can't see it, it's dissolved in the water. That's when you write aqueous, is when you dissolve something in water. So that's what that term means. You will definitely see that. Sometimes when you write chemical equations, you put the solids and the liquids and the gases and aqueuses in there. Other times, you do not. So you could write the same equation as just Fe plus Cl2 making FeCl3. These parts are not necessarily they don't necessarily have to be there. Okay, how would you write the skeleton equation for the reaction between carbon and sulfur to form liquid carbon disulfide? So in this case, we would have carbon, and in this we'll go ahead and put it in there, which is a solid, and sulfur. Neither of these are diatomic molecules, and we're going to form liquid carbon disulfide. So that di, as we remember, means 2, so it would be CS2, and that is a liquid. So I'm running out of room there, but you would have an L for liquid. Okay, notice again, these elements here are by themselves, but neither of them are diatomic molecules, so we simply leave them as a C and an S. Okay, now you'll notice a couple of things. If we come back here, you'll notice here that on this left-hand side, there's only one sulfur, but over here, there's 2. Up here in this equation, there's 2 chlorines here, but there's 3 chlorines on this side. One of the things I told you earlier is that when you have an equation or a chemical reaction, you cannot create or destroy matter. So if we have 1 sulfur on this side and 2 over here, it looks like we've created a sulfur atom, which you cannot do. And so what you have to do is you have to do this thing called balance. You have to balance the equation, which means whatever you have on the left-hand side, you also have to have the same amount on the right-hand side. So the amount of products must equal the amount of the reactants must equal the amount of the products. So even looking at that water example, when we had H2 plus O2 making H2O, you'll notice that on the right-hand side, right here, there is only 1 oxygen, but over here, there are 2. It looks like we have destroyed an oxygen atom, which again, you can't do. Okay, so since those values are not the same, since the oxygens aren't the same, we have to balance the equation. Okay, so we have to make both sides the same until we're not creating or destroying anything at all. So the way that we do that is we write the equation like we just did. We check both sides and see how many there are on each side. And then this bold here, this is the important part. We change only the coefficients to make the number on each side the same. Now let's go back here. Remember what the coefficients are. Let's come back to the very beginning. The coefficients are those numbers in the front. We can change that, we can change this, and we can change that. But that's all we can change. For example, with water, if you have H2 plus O2 making H2O, if you're and you're thinking, oh, I'll balance it. Okay, we need 2 oxygens on this side. Well, I'm just going to put a 2 right there. Well, when you put that 2 right there, what you've done is you've now changed your chemical formula. That's no longer water. That is now hydrogen peroxide, a very, very different substance from water. So you cannot do that. Again, the only things you can change the number that goes here, here, or here. So again, those are our coefficients. You only change the coefficients in the balanced equation. Okay, and then you write those coefficients in their lowest possible ratio. So in this case, we've got 2 hydrogens on the left-hand side and 2 hydrogens on the right-hand side. The hydrogens are already balanced. The oxygens, though, we've got 2 oxygens on the left, but only 1 on the right. So what you've got to ask yourself is, how can I change my coefficients to balance out those oxygens? Again, all I can do is I can put numbers right here. So if I have 2 on this side, but I only have 1 on this side, what do I need to do? Well, I can write a 2 right there in front of the H2O. And so what that means is now it means that I have 2 waters. So we know water looks like this, but now instead of 1 of them, now we have 2 of them. We've got 2 waters. So now we can see how many oxygens do we have all total? We now have 2. But what you've also probably noticed is by putting a 2 in the front here, we've also now created more hydrogens. We've got 2 hydrogens. We actually now have 4 hydrogens. And so over here on our left-hand side, we also need to have 4 hydrogens. And so now we're going to put a 2 right here. And so now on our left-hand side, we have 4 hydrogens. On our right-hand side, we have 4 hydrogens. And so overall, all that we have to do is a 2 goes here and a 2 goes there. And now our equation is balanced. Okay, so here's just some more, basically what I just talked about. Okay, and so there's our final answer down there at the bottom. Okay, so let's look at another example. And the way I do this is I just start with the very first element. I count 1 calcium, 1 calcium. The calciums are fine. I see 1 hydrogen. I see 2 hydrogens. Again, the only thing I can change is the coefficient. So if I have 1 hydrogen on this side and 2 over here, I have to put a 2 right there. So now I have 2 hydrogens on the left-hand side, and now I have 2 hydrogens on the right-hand side. Now, when we write 2 HCl's, what that means is we have 1, 2 HCl. So not only do I have 2 hydrogens, I also have 2 chlorines. And so, hey, how convenient, I've got my 2 chlorines on the left-hand side, and what do you know, I have 2 chlorines on the right-hand side. So that is a balanced equation. All we had to do is put a 2 right there, and now our equation is balanced. Okay, here's another one. 1 potassium, 1 potassium. 1 chlorine, 1 chlorine. 3 oxygens, 2 oxygens. Now, we can't have fractions, so what we need to do is we need to determine what's a number that 3 and 2 both go into. What's the smallest number that 3 and 2 will both go into? Well, obviously 6. So what number am I going to put in front of here to make that oxygen a 6? I'm going to put a 2 there. 2 times 3, 6. What number am I going to put in front here? Obviously a 3. 3 times 2, 6. So now my number of oxygens are equal. Now by fixing the oxygens, we kind of messed up the potassium and the chlorines. So all we need to do to fix that is put a 2 in front of KCl. So overall, we've got a 2, and a 3 to balance our equation. And now everything is the same on both sides. Okay, here's one that's a little bit more challenging. We've got 2 carbons on the left-hand side. I only count 1 carbon here on the right, so I'm going to put a 2 in front of there. And then I see 6 hydrogens on the left, only 2 on the right. So 3 times 2 equals 6. So now my hydrogens are okay. I count 2 oxygens on the left, but on the right, and here's where it gets a little bit tricky, 2 times 2 is 4, plus 3 more. Right now I have 7 oxygen atoms. This side I only have 2. Well, again, I can't have fractions, so I can't go 2 times, what would that be, 3.5 equals 7. I can't do that. But we do know that with any odd number, if you double it, it will turn into an even number. So what we want to do is we basically want to start over. Instead of starting with 1 C2H6, we're going to double it, and we're going to make that 2. Now watch what that does. If we double our very first thing, 2 C2H6s makes 4 carbons. 2 times 6 hydrogens makes 12 hydrogens. So I'm going to put a 2 there. Now let's look at our oxygens again. 4 times 2 is 8, plus another 6. That's 14 oxygens. Well, now our odd number just became an even number. So when you have that pop up when you're doing balancing equations, if you have an odd number on one side and it has to be an even number on the other side, you simply double everything that you've done so far. Remember before, this number here was a 1, this was a 2, and this was a 3. Notice how everything has doubled. And so now our odd number became an even number. So if we have 14 oxygens over here, we simply place a 7 there, and now our equation is balanced. So overall, it should be 2, 7, 4, 6. And that's our balanced equation. Okay, here's a more challenging one, because not only do you have to balance it, now we also have to write it. So you guys have learned how to write chemical formulas. So let's see if we can do this one. Sodium carbonate. So sodium is a metal. It has a +1 charge. Carbonate is CO3, 2-. When we make that formula, remember we're going to switch. We're going to take our -2 and we're going to move the 2 down. So the formula is going to be Na2CO3 is going to react with aluminum hydroxide. So we've got Al that has a +3 charge and an OH-, that's hydroxide. So again, we're going to switch them. So this 3 is going to come down here. So it's going to be Al. Don't forget the parentheses on OH. You do it all the time. Al parentheses OH3 is going to make sodium hydroxide. So now we can look at what we started with. Sodium is +1. Hydroxide is -1. So that's just NaOH plus aluminum carbonate. So aluminum +3, carbonate -2. That's going to make Al2. And then we're going to have CO3, 3. And I'm going to write this again. I'm going to move this over to make it a little bit easier. So we've got Na2CO3 plus AlOH3 is going to make NaOH. Notice I didn't use parentheses on that OH simply because there's only one hydroxide. And then Al2CO3, 3. Now in this case, now that we've written it, now we can start comparing both sides. So we've got 2 sodiums. Here we've only got 1 sodium. So I'm going to put a 2 there. The carbonate, and notice I'm going to keep that carbonate together. I'm not going to say 1 carbon, 3 carbons. I'm going to go, there's 1 carbonate over here, and there's 3 carbonates over here. So I need to put a 3 right there. Now, by messing with that carbonate, I also just mess with my sodium here, because now there's 3 Na2CO3s. So this 2 goes away, and that becomes a 6 to change my number of sodiums. Then for aluminum, I count 1 aluminum here, 2 aluminums here, So I put a 2 right there. And then again, this 2 not only goes to the aluminum, it also goes to the 3 hydroxides. So that makes 6 hydroxides. Hey, what do you know? This 6 we put here makes 6 hydroxides. So that is our balanced equation. 3 sodium carbonates reacts with 2 aluminum hydroxides to make 6 sodium hydroxides, and then just our 1 aluminum carbonate. Okay, so there's all the ones that we just did. Hopefully we did them all correctly. It looks like we did.